Hi all, I'm Ro, your friendly neighborhood developer. I've got some exciting things in store for you today. I'll show you how to quickly obtain a HTTPS certificate using Certbot and Let's Encrypt. We'll start with two basic things you need to know, namely, who is Let's Encrypt and what is Certbot. Let's Encrypt are a non-profit certificate authority that provide TLS certificates. A quick skim through their 2020 annual report shows that they're now helping to secure more than 225 million websites. Cool, huh? Certbot, on the other hand, is a free, open source software tool for automatically using Let's Encrypt certificates on manually administered websites to enable HTTPS. The appeal of Certbot is that you run it once to automatically get free HTTPS certificates forever. You can install it as a service on virtual machines, and it even works with cloud providers like Azure, where you're running your web applications as a PaaS service and you don't have terminal access. The approach I'll show you today is not automatic, but a manual approach. This is perfect for when you're keen to test something out quickly. For production scenarios, you might be better off using more automated approaches. So let's get started. We'll start with some prerequisites. Firstly, since we're getting a domain validated certificate, we need access to a domain and the ability to add a text record. In the example I'll show you, I have access to a domain called contosoelectronics.org and the DNS provider is Google. Next, you'll need access to a system where you have admin privileges. In my case, I spun up an Ubuntu server for this video. Probably a good idea to run some updates too. Now that we're done with our preparation, let's get ourselves a new certificate. The first thing we'll start with is installing Certbot like so. Here, I'm using the Snap packaging and deployment system to help me install Certbot. Now that Certbot has been successfully installed, let's get ourselves a certificate. We'll now run Certbot with the manual switch. We also let Certbot know that we're capable of providing DNS validation via the preferred challenge switch. We will also need to provide Certbot with some additional details like our email and the address of the Let's Encrypt server. An important step is to provide Certbot with our expected host name for the certificate. You'll need to know beforehand the host name of the web application you're trying to protect. In my case, the host name I'll be using is login.contosoelectronics.org. Once we run this command, Certbot will work with the Let's Encrypt service and generate a DNS text record, which we'll need to set up to help validate our domain ownership. You notice here that Certbot has asked us to set up a text record for our domain. You can see both the record name and value that it expects. I'll go into my DNS hosting provider and set up the text record as expected. Now, whatever you do, don't press enter just yet. If you press enter, Certbot will try and validate the domain and it'll fail. Only once we've added the record and verified that the text record is visible should we press enter to let Certbot complete the certificate generation process. What I like doing now is use the dig utility to interrogate DNS name servers to validate that my changes have taken effect. Dig is a domain information groper. You can run the command or use an online dig utility to do the same thing. If you don't see your text record, you can hit the fix button to try and resolve it. Once you see your text record show up, you should be okay to press enter on your terminal window and let Certbot generate your certificate. Once you press enter, Certbot validates your text record and generates the certificate. Since we use the current working directory as a working directory when requesting a certificate, you should be able to see it in a folder called Live in your current working directory. All done. Thanks for watching.